I apologize, guys, on the new tablet. The slides kind of cut off in the one section, but we'll work through it. So remember, for systems of equations, we want to be able to tell if a point is a solution or not. So to do this, remember, we want to sub in the ordered pair into the two equations. So we're checking for the 0.25. So we're going to sub in 2 for x, 5 for y, and check if it makes sense. So for this one, you can see that it checks this is true. Now, when you're dealing with the system, you have to check for both both equations have to be true. So again, we'll plug in. Make sure you check your signs so you don't make a silly mistake like I just did. Oh, sorry, guys. All right, so again, it's true. So we're going to conclude the 0.25 is a solution for this system. Okay. All right. We're going to do the same thing for the next one. What we want to check here is 0.25. And now we're going to look at the next system. So we're going to go ahead and plug in -2 plus 2 times 5. Does that give us 8? No. -2 plus 10. It is true, that does give us 8. Okay. 3 times 2 minus 2 times 5, does that equal 0? 6 minus 10 gives us 4. It's not equal a -4. Sorry. So that's false. Therefore, we conclude 2,5 is not a solution for this system. Okay. Remember, I'm going to upload this as a PDF as well, but I think these videos help you guys, prepare a little bit for your test. You can pause the video, that kind of thing. Okay. All right. So this is going to be a refresher for me in class. We did cover this in class, but I'll go ahead and do it again. So remember, when you're doing graphing, this method is by graphing. So okay. what we got to do is we got to solve for y. So we'll do the first one, 3x minus 2y equals 6. I'm going to subtract 3x. Gives us 3/2 minus 3. Okay, and then I'm going to find the other one before we go ahead and solve onto the graph. So that will be x minus y equals 1. Subtract x on both sides. We get y equals x, positive x, minus 1. Let's do that one first. So we're going to come to -1 on the y-axis. And we're going to go up 1 to the right 1. 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 All right, you just keep going. Right along this diagonal here. And I wish I could connect dots better, but I always end up missing one. Okay, so that's, and I'm gonna write the original, so minus y equals 1. Okay, now let's do the other one. Okay, and we'll go to -3 on the y-axis, and we're gonna go up 3 and to the right 2. And then we'll go up 3 and to the right, up 3, up 1, 2, 3, to the right 2. There it is. Up 3, 1, 2, 3, to the right 2. Up 3, 1, 2, 3, to the right 2. Okay. Down 3, to the left 2. Down 3, to the left 2. Okay. And again, we'll use the original. So this is 3x minus 2y equals 6. And here you can see it overlaps right here. Okay. We have our overlap right there. And that point is 4, 3. Okay. All right. Good. I apologize, guys. My video is not starting. You know, the one for my face. So you'll have to do this one blind. Just know that I'm here. All right. Again, you'll be able to get this off the PDF. So don't worry about writing it down right now. Okay. We did this one in class too. Remember, this was using substitution. So method sub. Substitution method. So what we're going to do is we're going to take this x. Right now, this x equals 3x plus 2y. Oh, there's my screen, guys. It's a little messed up, but oh well. Okay. All right. So what we're going to do here is we're going to sub in our 3x plus 2y into the other equation. And what this does for us, right? This tells us that, get some Polk colors going here. This tells us that we now have gone from a two-system equation, or two-equation system with two unknowns, to now just one equation with only one unknown. And you can solve that. You can figure that out. Okay? All right. Excuse me. All right. So that's 12. 8y minus 3y equals 32. So that gives us, let's do the minus 12 here. And this gives us 5y right here. So 5y equals 20 divided by 5 divided by 5. So we have y equals 4. Now y equals 4 is not our answer here. You know, we're not done. We have to find a point. We no longer can just do you know, one variable answers here. So what we have to do now is we're going to take this y that we just found. I'm going to plug it back into the equation that we substituted, that we used to substitute for, and find x. So we'll have x equals 3 plus 2 times the 4 now. 3 plus 8. Okay, so your point, your overall answer though, should be a point. So it should look like this. All right. Okay. All right, so this next one, so here we got some steps for you. It's okay if you want to write this down later, or if you just want to refer to it from the PDF, however you want to do it. So here's what's nice is here again, look at what we have for the y. Okay, the y has a coefficient of 1. Okay, and the only thing is that it's not by itself. So what we're going to do is we're going to get it by itself. So 5x plus 7. Nope, sorry. Went too fast. 5x plus y equals 7. Going to subtract 5x. So y by itself is negative 5x plus 7. So now what we can say is, well, we have a good candidate here for substitution. Oh, apologies. Still getting used to this S Pen. Okay, so now that we have this right here, we're going to take it and plug it into the y down here. Okay, so we're going to have 3x minus 2 times minus 5x plus 7 equals 21. We're going to distribute. So we're going to have 3x minus negative 2 times a negative 5 is going to give us positive 10x minus 14 equals 21. We're going to add 14 to both sides. This right here will give us 13x. All right, and then we have 39. Nope, 35. What did I do wrong there? Oh, here we go. Look right here, guys. Missed that right there. That's okay, we can fix it. That's why there are erasers, even digital ones. Okay, there we go. So it goes 39. We're going to divide 13 on both sides. So x is equal to 3. All right, again, now we have to take this x and here's what I recommend doing. You always want to go back to the original. So even though we rewrote it, we want to go back to that original problem, and we'll do it over here. Kind of looks like a guitar, right? A little bit. So we're going to do 5 times 3 minus y equals 7 is 8 minus y equals 7. Subtract 8 on both sides. We have negative y equals negative 1. Divide by negative 1. We have y equals 1. So now what? Man, guys, if I didn't have this on recording, I probably would deny what's going on. Obviously, it's been a long day for me, and again, another long day. I do apologize. I hope you guys have been pausing the video and figuring it out and then looking back. My apologies. Right here is a multiplication, not an addition. So we're going to do 15 minus 15 minus 15, negative y equals negative 8. Divide by negative 1, divide by negative 1, y equals 8. So all that really shows you though, guys, is that anybody with any level of math can still make a mistake if they don't pay attention or if they're a little bit tired. So I want you guys to take a positive away from that, okay? All right. Let's keep going. Okay, so this is going to be a good example for elimination, although, so I did use elimination, although look here, guys, what do we have right here? Right here we have that y with a 1 coefficient. So let's do that again. Let's see what happens when we do this, okay? So we're going to do substitution again. Okay. Go ahead and rewrite it. So 2x plus y equals 2. Subtract 2x on both sides. So then we have y equals negative 2x plus 2. And we're going to take this now. I'm going to take this and we're going to put it back in for y. It's going to be pretty gross. We're going to plug it into there. But I think before we plug it into there, I want you guys to take a look at something. So right now we have 1 over 10x plus 3/5 y equals 2/5. So what I'd like us to do, I want to get rid of those fractions, okay? So we're going to multiply each fraction by 10. Okay? That's not an exponent. We're multiplying. Okay? So what you're going to get in the first one, you're going to see here the 10s cancel. And then here, the 5 and the 10, that becomes 2. And again, the 5 and the 10 becomes another 2. So we're looking at a better equation now. We have x plus 2 times 3 will give us 6y. And 2 times 2 will give us 4. And now we're going to take this, plug it in for our y. So x plus 6 minus 2x plus 2 equals 4. Going to distribute x minus 6 times a negative 2x is a negative 12x. 6 times 2 will be a positive 12 equals 4. Going to subtract 12. We'll bring this together. That's going to be a negative 11x. And this is going to be a negative 8. And that is correct for the x. Okay, so I like that. Okay, but we're not done. We're not done, because now we got to take this x and we got to plug it back. And we actually can plug it right back in there, because all that's going to do is save us time from rewriting it. So let's go ahead and plug it in. Find y. -2 times 8/11. Now, the reason why you often want to go back to the original is just in case you made a mistake, but I know that that's the right x, so we didn't make a mistake. All right, so -2 times 8 will give us a -16/11. Now we got to get the 2/11, so that would be 22/11. Okay, because 1 times 11 is 11, 2 times 11 is 22. And then when we finalize this, 22 minus 16 will give us a 6/11. That is also correct. So our point answer is going to be 8 11s and 6 11s. Okay. You might need to go back and pause that a couple times. So that's a long one. Okay. This is definitely the longest lesson that I hope we have this semester. It's definitely a long one, the system of equations. Okay. So we are going to eliminate y now. Elimination is the best method here. Okay. So -2y and 2y, they eliminate. We end up with 13x equal to 0. Divide both sides by 13. X is 0. Now, if we plug back in, it doesn't matter which way we plug back in, because we didn't really do too much with any of that stuff. This is a 2, not a z. So the 5 and 0 go away. So our point then, point is 0, -9. Okay. All right, again, this is just your steps for elimination. You can either write them down now or you can write them down after. All right. We're going to go ahead and do elimination again. Okay, so we're going to multiply top by, we're going to eliminate the x this time. So we're still going to multiply by 5 and 2. So we're going to end up with, let's do another color, 10x minus 25y equals 5 times 14, 70. And then we got 10x plus 4y equals 12. We're going to subtract the bottom. So that means some sign changes. So negative there. This now becomes a negative, and this becomes a negative. So it's like we multiply by -2. Okay. Now, our x's cancel. -25 and -4 will give us a -29y. Let's write it nice. And then 70 minus 12 is going to give us 58. Divide both sides by -29. And we have a -2. Okay, so now that we have that, we're going to go back and plug it in. So let's just pick the bottom one because those are all positives. 5 times x, 5x, plus 2 times -2 equals 6. 5x minus 4 equals 6, plus 4 on both sides. 5x equals 10. We're looking at x equals 2. So our answers here are 2, -2 is our solution set. Okay. All right. Here what you're going to notice is, let's just go ahead and multiply the top by 3. And instead of writing it anywhere else, we're just going to write it right down here. So that's going to give us a -6x, positive 15y, and a positive 18. So what you notice here is that these variables disappear. They cancel out. So we're just left with 0 equals 22, which is a contradiction or a false statement. Okay, so because of that, we have the solution set of either the empty set, it's written like that, or you can call it the null set. That is not 0. Two different things. Either way. Okay. All right, this happens when we eliminate both variables. Both variables are gone, but we do not have a true statement. We have a false statement. All right, that's when that happens. Okay, let's do this one. Right away, you should notice there's a pattern here. So you could go ahead and solve this by substitution, because we do have an x here by itself. The other thing you can notice is if you multiply everything here by let's multiply everything here by a 3 on top. And again, we're going to bring it right down underneath. 3 times x will give us a 3x. 3 times -3y will give us a -9y. 3 times 7 will give us positive 21. Now what you need to realize is that all this cancels, but it becomes a true statement. Okay. Since we have a true statement, we have a few different ways we can write the technically correct most best answer. So you can either say, and this all basically says the same thing. I'm going to explain it to you guys in words in a minute. So that's one option, and I'm going to tell you how to read it in a second. The other option is you use the other line. Okay. And you read this as the set of all ordered pairs x and y such that and then either equation. So you can finish it out either way. Okay. Now, in all honesty, what this is saying is infinitely many solutions. So no matter what point you pick, you're going to have a true statement. Okay, that's what this wording means. So these are basically the same thing. Those are the same thing. Okay. So we just saw one. Actually, we just saw both of these. We saw a no solution with a false statement, and we saw infinitely many solutions with the true statement. So we're just going to see two more here, and that's okay. It's extra practice. That's all right. All right. So here's the first one. What we're going to do here is we're going to write the equation of each system in slope-intercept form and use the results to determine how many solutions the system has. So first, let's get these into slope-intercept. So remember, that's going to be, recall that's y equals mx plus b. So bring this on over here. We're going to rewrite it, 2x minus 3y equals 3. We're going to subtract 2x on both sides. That's going to give us negative 3y equals negative 2x plus 3. Divide by negative 3, divide by negative 3, divide by negative 3. So you are looking at y equals 2/3. Let's make that a little bit nicer. 2/3. Sorry guys. X minus 1. Okay, that's one equation. Let's do the other equation. Let's do this one. We're going to do 4x minus 6y equals negative 6. We're going to subtract 4x on either side. Divide by negative 6. Okay. And then let's bring it up here to simplify it. We're going to have y equals negative 4 over negative 6 is 2/3. But negative 6 over negative 6 is positive 1. So let's talk about that. What that means. That means that we have to conclude same slope, different y-intercepts. So therefore, parallel lines never intersect. Okay, so the very short answer of that would be no solutions. Okay, but that's the complete way that you write it out. All right, last one, and then I'm going to close this one down, and I'll it'll be one video, and then I'll do 3.1 as a 3.3, sorry, as a separate video. Okay, so remember, same thing here. We're gonna write into slope-intercept form. Okay, and then determine how many solutions. All right. So let's do that. Let's rewrite this guy first. So 5y equals negative x minus 4. So just got to divide everything by 5. So we're looking at y equals negative 1/5 x minus 4/5. All right, then we got to work on the other guy. All right, and we'll do it down lower so we can bring it up. So actually, you know what? That's a pretty nice one too. And bring it a little bit further up because it's only going to be a couple of times. So we're going to divide everything by -10. Okay, that's going to actually give us y -2/10 x minus 8/10. Well, this can all get divided by 2. So you end up with y equals -1/5 x minus 4/5. Okay, that tells us, oh, sorry guys, that tells us that both equations, both are same slope and same y-intercept. So same line, which really means infinitely many solutions. All right, I'm going to see you guys in the next video. Thanks so much. Hope this helped you out.